Hey folks, welcome to another episode of CockroachDB Bites. I'm Jon St John, I'm your host. Today we're going to jump into the architecture series, the first session on what is CockroachDB. So let's go ahead and get started. So there's our agenda for this series. Let's jump right ahead. So when I talk to folks about CockroachDB and try to explain what it is, there's a few things that I like to talk about, and I've got 3 slides here, and we'll spin through them pretty quickly. First important thing is that it's a distributed relational database, okay? It's SQL-based, and it can be used for what we call mundane or high-value workloads. So a mundane workload would just be like an everyday workload, general-purpose database, and a high-value workload. Typically, I think about that as something that needs high availability, that can't tolerate any type of data loss or failure. So CockroachDB itself it's a distributed database. It functions as a cluster of nodes, and you can see that pictured on the left where we have these purple circles, and the cockroach inside represents a node. And we have that split up into different availability zones within the same region. So we've got US West, maybe a cloud provider region, and we have each of these nodes that are connected to each other and communicating with each other. And then at the top we have different users, Ashley, Lindsay, and Peter, that are interacting with the database. And the database itself, even though it's got all these different nodes, is represented as a single logical database. So those users can connect in to any one of those nodes, and they can interact with any part of the data, and they don't really need to think about what they're interacting with. So there's a few really strong selling points for CockroachDB. There's actually a lot, I would say, but the 3 that generally push folks over the edge to use Cockroach are typically scale, high availability, and multi-region deployments. Now, you don't need to have one of those major pain points to use it. There's lots of other good reasons to use it, but just touching on the scale component is that it's easy to scale. We could, for example, we could add a 4th node in that first availability zone on the left, join that into the cluster, and the cluster itself will just automatically rebalance, and it'll have that much more additional capacity for both reads and writes. So you can imagine you can then scale just by adding more nodes and get the throughput and potentially the latency that you're looking for in the database. And that's fantastic. Anyone that's worked with databases at scale knows how difficult it is to deal with a database that has like a single writing node or VM, and trying to scale that up, and eventually you hit a ceiling, you have to do sharding and those type of things. So the second part that I mentioned is high availability, or sometimes we just call it resiliency. And that's Cockroach is naturally resilient, so you can survive the failure of a node or even an entire region without any service disruption, right? So as a distributed system and the way it's set up, there's different ways to configure Cockroach, but this, in the picture here, we just see we lost all of the nodes in maybe an availability zone. And as long as the user requests and the client are getting rerouted to nodes that are still up, you're still going to have all your data functioning. You're still going to be serving reads and writes, and you can, maybe that failure resolves itself. You can bring those nodes back on, or you can just build out other nodes, join them into the cluster, and the cluster will rebalance itself. So high availability and resiliency is really important. I oftentimes think about it in terms of high availability because that includes both the resiliency, but also the ability to do things like online schema changes, as well as rolling upgrades. So you don't need to schedule downtime, say for a database upgrade. You can just upgrade a node at a time in a rolling fashion, and that cluster will stay online. So, and finally, the last part is just that CockroachDB really excels at multi-region deployment. So in this picture, we have 3 different regions: US West, US East, and EMEA. And users can connect in to any node across the entire cluster, across any region, and still have access to the same data. logical data. But in addition to that, we also have powerful tools to be able to geolocate data near users to reduce latencies, or even to comply with different types of regulation, say, for example, GDPR or other type of regulation that requires data to be physically located in one place. Besides being able to specify where your data lives, we also have a lot of really powerful tools for reducing latencies for different operations on the data. For example, follower reads is one of them, global tables. And each of those are there's a lot of different tools you can use to deal with the fact that you have this cluster spread out over potentially a global surface area. So that's a really, really quick intro to CockroachDB, and thanks for joining. On the next one, I'm going to talk a little bit about cluster architecture and kind of high level on like how the nodes connect and what's in the nodes, and then after that, we'll jump into the software stack itself. Thanks for joining.